Okay. And we'll share screen. I think we might actually be good. Look. Yeah. Sorry to. Yeah, I think we'll come. All good. No worries. Down in front. Okay. Right, see ya. Okay. So here we are. Looks good. Looks good. Okay. Hi everyone. No one else is here. So Carl's joined. Hey Carl. Yeah. So I'll keep an eye on the Zoom call. See if more people join. If no one else does, then I guess not. So welcome to PCB Design Workshop 1. I'm delivering this to people that I all know. So this can be a lot less formal, a lot more casual, I feel. But I am recording it, so I think maybe I'll keep it a little formal. But please don't expect too much from me. So basically, yeah. By the way, this microphone will pick up like everything actually. Let me just, yeah. There we go. Okay, now I'm just changing the angles so that way I can walk around and it should pick up my voice still fine. So basically today's workshop will involve getting familiar with PCB fundamentals and going through LTspice. This will lead into actually doing board design next week. Now, I know a few of you are very familiar with this, and maybe aren't so familiar with this, so I've catered this workshop for like beginners, so that's where we'll be at. And doesn't want to look at the slides. Wow, University for Technology, am I right, guys? Yeah. There we go. Okay, cool. So workshop 1, PCB fundamentals. This is this week. Next week we have actual component selection and board design using Eagle. Week after is catch up for the people who missed out and stuff and fall behind. And week 4 is solving a PCB safety information and stuff. Workshop 4 is probably going to be the most fun. But everything else leading up to it is good too. This one's probably the least fun actually, kind of sadly, but it's still interesting. To get started off, please make sure you hit LTspice. Literally just go on Google, first link, go down to download it and just download it. Let you get started with that. I'll keep talking while you guys are doing this as well. That means you can actually get a move on while you do it. It's pretty monotonous. Okay, so PCBs. What are they useful for? Well, I mean, these were what I could think of about 3 in the afternoon today. These were the things I thought of PCBs. They're cheap, they look nice, they're durable, they're mountable, components and robotics and stuff. They're also quite throwable. They make it with frisbees and stuff. Don't throw that at someone's safe tip. It's a bad idea. They can be sharp and they can hurt somebody. But you can do that with them. Anyway, and that puts us straight into LTspice. So in terms of PCBs, you may have seen them actually. You'll see them in computers, anything. You guys are all engineers or have done computer stuff, so you should be familiar with how they're used. We can use them for everything from power delivery and advanced circuits to actually very small things, stuff to do with signals and stuff. They're everywhere in the world of electronics. I'll wait until you guys get into LTspice and then we'll keep going with it. Yeah.
This is LTspice.
Yes.
The Samsung.
You see Samsung on the title, it's going to use some fancy music.
Yeah.
Okay. You guys in here, open up a new project and we'll get started. So, LTspice. Previous slide, just the new little play icon up there. Okay, so introduction to LTspice. The first thing you should know about is the ribbon. This is where all your stuff happens, everything interesting, all your controls. It's like the ribbon in Word or whatever. You should be very familiar with how useful these can be. Now, there are some important hotkeys to remember. You have wiring, move components, undos, redo, and delete. This stuff and rotate is coming later. This stuff is all obviously doable in the hotbar, but like hotkeys obviously get easier to remember. I'll be going through a lot of stuff up here, but some things that I'm not going to actually would be copy, search. These things aren't so important, but these are. So what do we have? We have first component we're going to be looking at tonight are resistors. Those of you who have done EGB 120 would know what these are, or done general electronics at all. Resistors used for a lot of things. Hotkey for them are in the LTspice. You can place them as easily. Top field lets you change the name. That's good for referencing later on in your circuit. like if you want to name this as certain things. The R value on the bottom, we can click on that and it lets us change the value for it. Control R, this is really useful, is used to rotate components. That's any component, even touch resistors. One thing in LTspice is that you do have prefixes. Instead of having to type out a billion zeros for everything, just use prefixes, save you time. 100K and 100,000 are both the same value if you type them in LTspice. In fact, LTspice will actually abbreviate 100,000 with multiplication for you. Okay, that all clear? Any questions?
Yeah.
Cool. Other components, we have capacitors, diodes, and inductors. And this is what they look like. We use the hotkey C and D for capacitors and diodes. I don't think inductors have a hotkey because no one uses them. They're kind of crap. Actually, no, they are important. They do have applications in electronics, but we don't often use them. L, yeah, that makes sense. Yeah, so you often use inductors no matter what power electronics and stuff.
What does an inductor do?
Inducts current using a magnetic field, coil stuff. I haven't used them much either. So
I'll believe you, I'll take your word for it.
yeah. Capacitors hold charge, if you call it that, and diodes are kind of like a one-way valve. That's another way of thinking of them. It's a very basic way of viewing it, but it's basically squeeze and get the side of the pain. Yeah, also one thing to know is that if you write it directly on the component, you can actually fine-tune the characteristics of the component. Everything from like forward voltage, reverse voltage, like all the really fine-tuning stuff like tolerances and that sort of stuff can all happen if you write it on the component. Then we have the components library. So also you may have noticed that your resistors, capacitors, inductors, diodes, and other things are all actually up there on the hotbar already for you. You can grab them from there. Otherwise, other generic components that may not appear on the hotbar can be found in the components library. So if you have a look inside of it, open it up, you can see there's a whole bunch of stuff in there. Key things in there are voltage sources. They will often have pre-done components as well, so like actual components that are used in industry. They will be already there with their tolerances and fine-tuning components already set up for you automatically. Yeah, that's how that works. Any questions? All good? Okay. One other cool thing about LTspice are nets. Here we have, I've circled two nets here. I've got ground and custom nets here. Basically act like a direct wire. So if you label 2 points on them, it basically functions as like a direct wire to them without you having to actually draw one. It's particularly useful when avoiding messy schematics and stuff. Because if you have like wires everywhere, it's hard to tell what's crossing, what's actually touching what. It can be very good. Ground, also known as use a G, it's a triangle symbol down the left side. 0 volts is where the battery should go. That we want to have there. One thing to note as well is that if you have like a voltage source, then if you have like a 5 volt forward voltage source, like on this slide, the negative component here, if this is a 5 volt source, this here is negative 5 volts, not 0 volts. So it's not a DC voltage. It's not 0 volts until you attach ground to it, then it actually works like a DC voltage source. So your first circuit. Based on what we've gone through the last 3 things, can you guys try and build a basic circuit that uses a 5 volt voltage source, 2 resistors, and a capacitor in parallel? You guys know what parallel circuitry is? Yeah. And a ground label is 0 volts, and that's going to come out to 0 volts out of the back of the voltage source. And you can also label the 5 volt output as VCC using nets. Okay, go. And for those watching at home, specifically Carl, how you doing, dude? Good to see you. I can't hear you or see you, but if you message chat, I'll be able to see what you're saying. Check me in Mark's computer too. So what I need to go in the components library and just type in voltage and search. All that. Yeah. You can also search for components in the components library there too. That's also an option. I want drag. You can. I think F7 is one of the drag keys. One of the things in the hotbars also.
That's left.
F8. You just let you click on something and then it can just stop rolling around.
I mean, like the drag the screen around.
Click escape until you have to be sure, then just drag around.
Right.
Yeah. No, this stuff gets actually really tricky once you start doing Eagle, because Eagle is another software where we also do schematics.
Yeah.
But the controls are different. So it's like often you're going back and forth between LTspice and Eagle when you're designing a circuit. it does get very confusing and pretty hilarious actually.
So we're doing three-way parallel.
Yeah, so three components in parallel basically.
How do you change the text of the wait, in parallel?
So if you right click one,
Yes.
particularly right click
Right.
on the direction change.
Not serious, in parallel.
Parallel.
But
Just remember when he asked, do you know what?
the hint is in parallel.
Yeah.
I was thinking.
That's great.
Okay.
Oh no, just you can do angles.
So I might go to the next slide. That's all right, guys.
You can click it and change it. Yes.
This is something you should read about roughly.
Oh look.
Okay. So here we have a 5 volt voltage source, two resistors in parallel with a capacitor in parallel, 10K, 1M, 10 ohms for the other one, and then the ground connection at the bottom. Okay, so signifying 0 volts. Okay. Any other questions? Just do LTspice.
Eagle doesn't do circumambulation, does it, or does it?
Do what now?
Like actually do circuit calculations.
No.
Yeah, I don't think so.
Eagle is literally just like whatever you put on
Schematic,
it, it'll just, yeah, it's just schematics.
I've seen it used for PCB.
Can I make my computer simulate a computer?
Yes.
Probably, yeah.
You should use Minecraft. Makes it simpler.
Okay, so how does this actually into PCB design? So we're going to move into what's known as analysis, which is actually how we analyze our circuit properly. So transient analysis in this case, it lets us simulate how a circuit would run over time. There are also other types of analysis, AC analysis, DC sweep, noise, and others. Not important right now, I'm not going to worry about them. But they are important, they do have many applications, and they are very useful. We can begin a transient analysis by using the run button at the top on the ribbon. So it's just running that now, and see what you get.
I clicked OK and it said no analysis request
Yeah.
found.
So you're given this box form. So the first three boxes are the ones that are actually the most important in this scenario. We have stop time, indicates how long the simulation should run for. Time to start saving data, so actually this lets you ignore maybe the first second or whatever, if it's like transient, crashing, filling up with charge, circuit isn't stable yet. After a charge has been in from it, then it becomes stable, then you start recording analysis. It helps you get rid of just the useless data at the start. In this case, it might have a big impact on the circuit. And then max time step is actually how long the data entry is. The smaller this value is, the higher the resolution of the simulation, but the longer it will take. But let's just have more data points basically.
So if we do like 3, 0, and then 1.
So you want to set your time step to like something like 0.1 or 0.05 or 0.001 seconds or something. Obviously, yeah, the smaller and smaller it is, better resolution you have, but it takes longer to simulate. And particularly on big complex circuits, you want to balance that out.
You need to do it on far with everyone else.
So I would say I was actually not in the room. Yeah. Because, yeah.
Yeah, definitely.
So I'll go slowly for you, okay? I'll get that much further.
Yeah.
Okay, so transient analysis, LTspice. You notice one from the summers, a little bit of text would have appeared on the screen on your schematic. .tran, .tran 001, so 0.001 or whatever value you set up. This is basically introducing text and directives for you guys. So it's basically text and directive. Text here, which is the AA icon button on the hotbar. It's just used for commenting, if you want to go through your documentation and making sure you know what's going on, particularly in complex circuits. Directives are actually basically functions. They serve some sort of purpose and they're useful for a lot of things.
Imported line.
Yeah, mainly importing libraries, but also other things too. As an example, a simulation here, transient here, is a form of a directive. Okay, so run the analysis, and you'll notice that a graph is created when you run what?
Give you the professional.
Oh, damn it! Look, I wrote this in pretty quickly. I'm amazed that that's the only issue I've spotted with it. You know, I'll fix it right now.
If you whack. Wait, which type of save am I doing?
Okay, there we go, fixed. So if you hover your mouse over a wire, a approach should appear after you run your transient analysis. You can click on it to display the voltage at that point in the circuit on a graph. So obviously in this case, the only real places you can put are just 5 volts because nothing else going on really. Parallel circuit. So you won't look at capacitor at this point. However, you can also click directly on a component to see the current of that component over time. So particularly the capacitor here will show changes over time as the charge is up. The capacitor we use here is 1 millivolt, which is actually 1 millifarad, which is actually quite large. So it won't be charging up with 5 volts in a second. Roughly, it'll be so if you click on a wire, you'll also see that probe up here. When you hover over a wire, you can click on it to see what the voltage is at that point. Also, you'll also notice that you try to click on any wire that's connected to ground, nothing will appear. It's 0 volts, so why? Circuit here obviously is very complicated, and then also comment if you click on a component as well, direct on a component, you can see the current of that component as well.
We'll see.
Now, next slide is going to be the actual circuit that we are going to be doing on the PCB. Okay? Everything that you've learned in the last half an hour, basically, you just be applying on that. It's a complicated circuit. Please ask questions. Just set it up LTspice and see how it works. You can copy it. I haven't put that resource file on Facebook yet, so I'm going to do that now. There you go.
Oh my. Oh, that's fun.
Yeah, get to work. So this is what the main workshop is going to be about. It's just this circuit here. So if you go on Facebook, go to the PCB workshop series event, and in the discussion tab there'll be a post that'll have the link there. But it's a good op amp. Yeah. Now it's not the op amp that we're going to be using on the actual circuit. I've got another one. I couldn't find an LTspice library for this workshop. So yeah, no.
I didn't realize it saves bracket 1 because I already have it on the download. Oh, nice.
Wait, so I just need to put it in the same thing as
in the same folder as wherever your project is saved. I was just making a new project for it, a new project file. So I have a new schematic in LTspice and save it on my custom. Okay, so one thing as well, guys, here's the circuit you're actually building.
Oh, no. Is that a breadboard?
Yes, on a breadboard.
I love breadboards. Of course.
They come back to me.
What I'm going to do is I'll look it up to you.
Are you on?
No.
Okay.
Yeah, so what I'll do is I'll actually hook it up to Power Supply. Once you guys have done designing this, and you can see how it looks like in LTspice, we'll hook it up, see how it runs, see what it does, and I'll change the component as well and see how that affects it. And then we'll that'll be basically it for the night. Yeah. So they are very useful for testing. Basically, the design process for PCB is basically you build it in LTspice, then build it on a breadboard, then you design an eagle and get it manufactured.
Yeah.
Because once you send it off, you can't change it, right?
Yeah.
So on the first board that I sent, actually, I sent it off this board for this workshop about a week and a bit ago, and realized it was wrong after I sent it off. So I've changed it since then, and it's right now, but I'll have to like kind of do a crazy soldering job to make it work. Actually, no, it's just not going to work. Actually, I just realized it won't work. So I have to send another one. So I wanted to have it for next week to show you guys.
Yeah.
But my have to be in for after. Yeah, we'll just double check the circuit.
10K, 10K, 10K. Coming here, 2.7 meg. Yeah,
So we'll just run the circuit.
I'm seeing what's the value of the dial?
Oh dear, it is.
Is
Hold on.
meg supposed to be in pebbles or something?
Oh, okay, never mind. Yeah, I guess that's fine. Yeah. So one thing we will. Let's see. What's that? Sorry. Have a look at the circuit. Is this going to appear over here? No, let's drag this over. There we go. Just looking at the circuit. If you have a look at it over here, we'll see actually a nice kind of vibration happening here. Right. No, it's
That's why it's 7 volts.
because I'm scanning over here. Look at it after resistor. You see quite a lot drop. Now, if we actually reduce our resistor size here, and then run the simulation again, it freaks out. So this is a lot of this is actually due to the LMC6484 not being the same one as we're actually going to be using in our circuit. If you pull this one, this thing is known as a load kind of is a current limiting resistor in that you call it. 6 ohms. See if it comes up again. No, not quite. 81. There we go. Yeah, but you also notice we're getting a bit of drop, bit of kind of slew behavior here. This is our capacitor being too big. Okay, so it's not cleanly falling off.
So if you change to like what, 50 nano, would it be better?
If you made it smaller, yeah. We can also have a look at what our capacitor is actually doing over here. Charging, discharging, charging, discharging. Then the outputting wave is matching the discharges.
Oh,
So LTspice is very useful if you actually want to see how different parts of the circuit are reacting to each other.
that's where's the green line?
The green line is at the capacitor.
Oh, I see.
Yeah. Also, the labels up here will also be the labels of your diodes as well. So actually, the labels up here for your graph are the same labels as what EESS will be using. So as an example, if I do a probe over here, it's called VCC.
Gotcha.
Right? So if I'll label this line C1, whatever. As an example, grab this, we'll call it cap1, and drag that over here. Oh, hold on.
And this, it's part of the learning process.
Yeah. And then I run again, and then do a probe. Now it's called cap1.
In blue, which we can barely see.
Yeah, I'm not sure. There you go, cap1.
Oh no.
Yeah?
No, it's in the bottom left. It's so nice. It's so informative. Oh, like when you're hovering over the circuit.
Yeah, actually, yeah.
This is known. This is why I also this known. This one belongs.
Yeah, so.
It also tells you what particular section is connected to ground. So you just say like, oh yeah, this is just ground. So
Yeah.
This is ground.
oh, it's so helpful. At least with me, I suck. I suck balls when it comes to
It's very informative. This is ground. There's no full.
One thing as well, currents also appear, notice the arrow, it shows the direction of the current, then move down and to the left. So if you have a circuit that you want to have that's going this way, your current will appear as negative, for example, if you're looking through a resistor like that.
That is wild.
Yeah, no, the blue is not showing up very well on the, yeah, it's kind of bad.
Is it what's like to be color blind?
Yeah.
Okay, so now that we've done that, what happens if we change this one, R4 or C1? What happens to our simulation and how does it change? Go change it. Do it, go on. So either change the capacitor or change the big resistor, different values, and see how it affects your circuit.
100 femtofarads.
So if you change it makes it faster, right?
So yeah.
On R4, I can read the rate. Actually, there you go. So that was. Okay, so like with that,
If you set to 100 farads, it's not.
gigahertz.
Yeah, because in 10 years, yeah, I know.
Okay, also, yeah, if you feel like a capacitor big enough.
Oh, yeah, exactly.
100 farads, Jesus.
Well, that's 10 femtofarads.
Yeah. So, it goes way up.
Oh my god.
Whereas 1, 2, like,
A picofarads. Look. Picofarads.
Yeah, so it's 550.
That's cool.
Okay. So that's basically the workshop. Well, let me wrap it up. I'm going to plug the this circuit into the LTspice and actually have a look at it.
oh, so that also, so that slows it down because that's now okay. So this one's just, it's just taking longer because it's charging. So it's just now it's charging this one. But this is,
No, it's not. I can hear that.
Numbers.
Yeah, they run out of battery.
And then someone after me came, we were just doing things over this sort of space, messed up my group line, and had this group line. Oh, and I was like, oh no, oh no. Because it was designed to like pick up the Wi-Fi first, and then once it was connected, it was turning itself up. But someone tried to get it that with the Wi-Fi. And from there, I was just like, you know, when I tried to it's the most annoying child in the world. So that file system, you know, where that's like, so even if you have a big issue, it's somebody that you file system. So I was like, I can't fix this one day versus 80. And let them be another time.
Is it like it's not like, is it actually the same?
We do. So there's no other
Yeah, so it's pretty. Yeah, so.
Well, the game was a class, and then you go to take this switch now. You know, so I have to get one. And I realized,
So let's say,
I was like, okay, it's going to take me time. That's all. This is more I'm surprised when the calculation. The only problem is team and so even though it looks so good, how do you use the middle part? Because this is oh yeah, how many I was looking at something like I was like, and there were I was looking at one of those. This is wow. So this is pretty good. Yeah, there's all the charges of the time, right? It takes so long, right? We try to yeah. And also, we should have got another thing done. That's how you pass over the time. But then it's not there's like so they often they often is changing the state of the capacity. Oh, yeah, they're working through education, say that all don't worry. No, I didn't do it. Right, so I did basically all kinds of changes behind the levels. I would pay basically because they got very, very short. It's oh man, basically Okay. You guys focus really well. That makes a lot more sense. As to why you're using detection officer was so accurate. Now, well, yeah, possible. Oh, like, I like how the couch like underglow.
Yeah.
And the other company.
Yeah, it was lots. So they have that. So, yeah.
Oh, neither yet. It is illuminated.
So it's a set of red stuff. So it has.
That seems really good.
And then it has one stick.
Okay. I don't know. Oh, yeah. I was gonna say, how are you? Okay, that's fine. Yeah. Oh, that's just a very.
I was gonna say, show me.
This ball.
That's like.
Someone
I was saying-
I honestly, like, I think it's a style. Not a style,
I'm sure this is something.
Yeah.
This is the original one, but I don't make the sense. Oh, like Warriors playing.
Oh,
Yeah, that's what I meant. That's what I meant.
No, I'm not going to go through it. I don't know why I
the oscilloscope. Oh, literally the oscilloscope.
Okay, I'm gonna look in the chat.
I'll
tell you what.
Do you know how I made it? I can afford an oscilloscope.
So, yeah.
How much are these oscilloscopes?
They're like 400, 600 bucks.
Yeah, so for those recording, we just went over to the pacifier over there and actually ran the circuit and showed it off. All right, guys, that's the workshop. We're done.
Yay!
So finished earlier than expected. That's the workshop now. Next week, prepping week will come and I don't know if that's going to go.
I'll be up.
We'll be building that circuit in Eagle on PCB, on a board.
Nice.
Okay.
And so then the fourth one we actually solved that.
Yeah. Three holes is the way we're doing. All right. That concludes the meeting. Thank you guys for coming and yeah, see you all next time.